Alright, so number one, we got f of x equals this quotient as a quantity raised to a power of 9. So given what we know about the chain rule, if I want to take the derivative of the function, it'd be f prime of x equals, I start with the power that's applied overall. I bring that power down. I keep everything else inside the same. And then because I brought down a power, I have to adjust for that power. I subtract 1, new power becomes 8. Now where the extra part of the chain rule comes in here, we have to tack on to this the derivative of this inside portion. So since that inside portion is a quotient, we got to use the quotient rule. Using the quotient rule, I start with the derivative of x minus 2. Derivative of that is just going to be 1, right? 1 times bottom part here, unchanged, minus top part, unchanged, times derivative of the bottom. So derivative of the bottom is just going to be 2. That's all over your denominator squared, so 2x plus 1 is the denominator. That gets squared. There's the derivative of this inside portion. So applying the chain rule, that's the derivative of the function. We don't have to simplify at this point because we just want to see that we got the basic idea down. That's going to be your answer. All right, now if we look at number 2. If you look at the setup on number 2, we've got a product overall. We've got this piece here multiplied to that piece there. Since that's a product, we got to use the product rule. So taking the derivative here, use y prime, use dy dx. Product rule states you take the derivative of this first part. So as I take the derivative of this first part, I got to recognize that I need a chain rule here. Right? I take this power of 1/2, I bring it down. I leave everything inside the same. I adjust accordingly for the power I brought down. 1/2 minus 1. New power, negative 1/2. I now have to tack on to that the derivative of the inside. So x to the 4th becomes 4x cubed. 3x, that's just 3. And then 9 goes to 0. Got multiple terms here, so I need parentheses. All of this right here is the derivative of this first part. And if I continue now with the product rule, well, product rule states you tack on the second part now unchanged. And then the product rule continues by adding on this first part unchanged. But now we have to multiply the derivative of the second part. Once we do that, we've concluded that product rule, right? So derivative of the second part. Got a power of 6 applied overall. Got to use the chain rule. Bring down 6. Multiply by this quantity unchanged on the inside. That quantity now is raised to a power of 5. But tack on to that to complete the chain the derivative of this inside part. Need parentheses because we'll have multiple terms. Derivative would be on 10x to the 5th, 50x to the 4th, minus, for the 3x to the 4th, that'd be 12x cubed. There's your derivative of that function. We take the derivative of this function, f prime of x is going to equal, got this 2 in front of the trig function. That 2 is just coming along for the ride. As we look at how the trig function is set up, this right here is the quantity that's being plugged into the function overall. So when I take my derivative, I'm going to start by taking the derivative with regards to the sine part. So that derivative would be cosine. I've taken the derivative with regards to the outermost part here, meaning this inside part stays the same. But now you have to acknowledge the derivative for that inside part. Derivative of 3x squared plus 4, that's going to be just 6x, right, because 4 goes to 0. And if we're not asked to simplify any further, that's your answer. That's it. All right, on this one, trying to make sense of the function, let's actually start from the inside, work our way out, and then appreciate with chain rules. The idea in getting started with a chain rule is you start on the outside, work your way in. You've got, for starters, an x cubed that is being plugged into the tangent. But you have the tangent of x cubed that's being plugged into the cosine. And then you have the cosine of the tangent of x cubed being plugged into the sine. So trying to make sense of what's plugged into what. We worked from the inside out. Hopefully that's a little bit clearer now. What should be clear is that the outermost function we're dealing with to start, if we're going to use a chain rule, is sine. So if I take this derivative, I start with the derivative with regards to sine. That'd be cosine. I've now taken the derivative with regards to that outermost part, meaning everything that was plugged into the sine function here, that must stay the same. So it's kind of like I can check this one off the list, right? I've dealt with that one already. But now I go back and I look at what's left. What's left that I've not taken the derivative of? Well, going from the outside in, next I'd have cosine to deal with. So derivative of cosine is negative sine. That's the outermost function with regards to this function here, meaning everything that was plugged in, the tangent of x cubed, that needs to remain the same down here. So now I've taken derivative with regards to that cosine. I can check it off the list. But there's more. There's this tangent of x cubed that I haven't taken the derivative of. So if I tack this on, take your derivative for tangent. Derivative for tangent, secant squared. And x cubed was plugged into that tangent function, so x cubed needs to remain there, unchanged, because I'm only taking the derivative with regards to that tangent, the outermost function for this part. So I've now taken care of tangent, right? What remains? X cubed. So if I take the derivative of x cubed, being 3x squared, and tack that on, that takes care of that part. I've worked my way through, so I must have my answer now for the derivative.